Hello everyone, my name is Andy Tran. Uh, I'm going to go over the project that I'm doing is the predictive maintenance. So predictive maintenance basically it's something that you build to predict the something about to fail or is going to fail instead of waiting for something to instead of something is already failed. So we want to predict something that allow us to be more proactive. All right. So uh, in this case, uh, I'm going to do predictions uh, using a couple parameters like the temperature and the fan speed reported by the server. So in a in a data center or even a small business that has a couple of computers that they need to run those computers 100% of the time is very costly for the server, those machines to go down. You lose customers and you cannot do any work, even if you have a couple machine at your shop or something like that. So the main purpose of this study is to build an algorithm using neural network to predict something about to fail. So or is going to fail in the near future so that we can do proper maintenance, have some lead time to order the parts so that we can prevent downtime, um, you know, in the future. As you can see from this slide, there are, based on the vortex.com technical bulletin, it's saying that, you have most electronic components basically fail are due to uh, temperature overheating. And the overheating can caused by various, uh, you know, uh, uh, you know, uh, things. So, for example, a component about to degrade, it will produce more heat. And if you do a lot of, you put a bunch of load on a computer, uh, it will generate a bunch of heat. And so the reason is that the hard drive will spin a lot more, and it require a lot of power, more power, and it produce a lot of heat. And in turn, once it produces heat, the fan will speed will increase to compensate the to reduce the to produce airflow so that the heat can be decreased. So those are the two important parameters in my study. So one measure is to get the fan speed and the temperature. And based on those inputs, I can predict, you know, do I need to go to that system and take a look why the fan is cranking up and something is causing my system to produce higher temperature. Um, it can be dust, block the airflow. So that is another part of not just the components, but dust that you see everywhere that block the airflow in the computer system, which in turn produce more heat and increase fan. So this is very effective, you know, in term of prediction when to do you know proper performance on a computer system. So as far as the infrastructure, I'm using a couple machine in my home, running the Ubuntu, the latest Ubuntu 18, um, I think 10, 1804 for long-term support, and um, I'm using PySpark, Spark, and Anaconda notebook. As far as the data set, because it's nearly impossible to collect to get the data, the maintenance data from the public big data website. So to be more realistic, um, in this case study, I'm going to generate the the data based on the data that I query from those computers using the um, public uh, industry standard RESTfish API. So all the vendors, nowadays, uh, including Dell, Cisco, HP, and so forth, they provide a mechanism that you can actually um, query the server using REST API or RESTfish API. And as you can see here is a couple of screenshots and showing that the sensors are reporting within the server, and the fan speed is how much the percentage of the fan, and its status. Um, the Redfish API is a industry standard. Anybody is not proprietary. You can query the system just using a simple, curl command or a Python script, and basically you just connect to that system and collect whatever data you want, and it's all accessible to everyone, and it's fully documented on uh, the MTF Redfish API website listed here, or you can go into the vendor like Hewlett Packard or Dell. They have uh, some pages that are fully documented that how you can access those uh, the data from the servers. You can build your own monitoring monitoring system, or you do whatever you want, and the data is fully accessible. As you can see on this slide is that I did a query on one of my machine, and I get back a JSON, and basically it's you can see there's a fan speed and the temperature reading. That fan speed is reporting in percentage, and the temperature reading is in Celsius. You can convert that into uh, Fahrenheit easily. And before I go into the uh, you know into the how I process the data, um, uh, is that nowadays the most vendors, there are so many software out there that do monitoring and send you alert, but basically they just send you alert, and once you get the alert and it's critical, pretty much your machine is gone. So the ideas of this study is that you want to predict based on the score, the warning output, not the critical. So once you get the warning, uh, you know, um, output from this, model, you want, you can start, you know, uh, you know, uh, go in and take a look at your system instead of, you know, getting a critical and pretty much it's too late. Um, so here I'm loading my the data which I generated. The data basically has a three columns: severity, temperature, and fan speed in percentage. Temperature is in Fahrenheit, and the severity is basically is either normal and and warning. Uh, Here I transform the data. Basically, I change the severity normal to 0 and warning to 1. So when I run the data through my model, it produces a something either 1 or 0, meaning that 1 I need to it's a warning. I need to take a look at my machine. Uh, Here I reorder the, the columns, and as you can see here that I looked at the data. Most of the data, the warnings are in the top quadrant, and the normal data points are in the lower column. Uh, as far as the model, um, the neural networks, it's it's using the derivative and the activation function. Um, so the main reason why, and there's a sigmoid function. Sigmoid function basically, um, uh, it's a curve-like shape. So we want to, the reason why we use sigmoid function is that because it's pretty much fall between 0 and 1. And the derivative, as you can see on this slide, here is that when we, uh, you know, you know, when updating the curve, we know exactly how much, uh, to change the curve depend on the slope. So that's why we use differentiation in neural networks. And as you can see here is that um, the model is being trained and it's calculate the cost. So it's the activation function. Um, it's a thing that we add to the output to, and is known as this transfer function that attach to the uh, between the neural network. So it is used to determine the output of the neural network, like something yes or no and 0 to 1. Um, Here that predicting based on the data that I'm fit into my model. I fit in, uh, you know, uh, I get an output of either 1 or something much less than 1. So anything that 1 indicates that I need to, that there's something wrong with my system. So I need to go in and take a look, you know, at my system and do some kind of maintenance, either clean it up, clear the fan, clear the airflow path, or some component that require replacement. Um, um, so that's the accuracy of my prediction. The How do I validate a system? By feeding the whole data set and plot the data set you know on my chart. So basically, as you can see here, that um, most of the warnings are in the upper quadrant, and the other normal data set are in the lower quadrant. This is equivalent to the raw data set which I visualized earlier. So I can confirm, based on that, I can say that my model is pretty much very accurate. Um, um, the study that I'm doing is only using two parameters, or or inputs. It's a temperature and the fan speed. But in the future, there are a lot more than just fan speed and temperature that we can look at. We can use for predicted maintenance. So with this model, there's you know only uh, you know uh, with this neural network model, I can easily plug into additional parameters. Um, Based on this project, I have learned how to use neural networks to predict something that you know, I can use a neural network to predict something that require, proper maintenance, schedule maintenance, or something like that, instead of waiting for something to fail. Uh, that's the whole idea of this study. Thank you very much.